start with polynomials. So this is second chapter of standard 9th. Now first question, so 2.1. Question number 1. Which of the following expressions are polynomial? We need to find which of the following expressions are polynomial. So what we call polynomial? Whenever any expression is there with certain power, like if suppose it is y square plus 2y plus 5, if there is certain degree, it can be either 3, it can be 2, or it can be even 1, or any other high degree. They are called polynomial. The condition of an equation not to polynomial, there should not be the degree half. Okay, degree should not be in fraction. Like if y is under root or x is under root, we don't call it as polynomial. And the next condition, this variable's alphabet should not be in denominator. Like there should not be 1 upon x, 1 upon y, or any other alphabets. So these two conditions we need to follow out to make any equation not to polynomial. Rather than if there is any power, we call it as polynomial. Depending on the degree, there are different kinds of polynomial. In our syllabus, we are having linear polynomial. This was in standard 8th, where the degree is 1. If suppose equation is x plus 2 is equal to 0. Or sometimes we have 3x plus 2 by 3 is equal to 0. Here number can be in fraction. I told there should not be any variable like any alphabets in the denominator. Okay, variables can be in fraction, but alphabets should not be in fraction. So this is a polynomial in one variable with degree 1, which we call linear polynomial. If there is degree 1, we call it as linear polynomial. If there is degree 2, here the highest power is 2, so this is degree 2. This is also a polynomial. See, one more condition, whenever any equation is polynomial, we should not make it equal to 0. So this is most important condition which you need to remember. Any equation, it should be only in equation form, there should not be any 0. If there is no 0, we call it as polynomials. And the next one, linear polynomial, when degree is 1. If the degree is 2, it is called quadratic polynomial. With degree 2 is called quadratic polynomial. And then if degree 3 is there, then we call it as cubic polynomial. So thus there are three types of polynomial. If the degree is 1, we call it as linear polynomial. If the degree is 2, we call it as quadratic polynomial. If the degree is 3, we call it as cubic polynomial. Now let's start with our first question where we need to make like whether the polynomial is having, whether the equation is polynomial or not. So here the first question is 4x square minus 3x plus 7. Now in this equation we have the degree 2. So degree of this equation 2. If they'll ask about degree, it's 2. But in this question they're not asking whether it is a degree, what the degree of the equation. They're asking like whether it is polynomial or not. So we'll write that as the given equation is a polynomial with the degree 2. And moreover, it is a polynomial in the single variable. Here there can be different variables. I used with x. There it can be either x or y, z, some other degrees may also possible. I used here x only. In the question only x is given. So we call it as S. The given equation is a polynomial with degree 2. Now the second equation, it's given y square plus root 2. Here you can find that the number is having root. I gave the condition there should not be any root in alphabets. So this is also polynomial and then with degree 2 as power is given 2. Now the next third question, it's given 3 root p plus p root 2. Here you can see that there is the root on t. there should not be any root on. So here root is on the alphabet. So whenever there is any root on alphabet, it means power is half. There should not be power in fraction. So it's not a polynomial. Now fourth question. It's given y plus 2 upon y. So as I gave the condition, even the alphabet should not be in denominator. Here 2 is in denominator. So this is also not a polynomial. With only two conditions, we can classify whether the given equation is polynomial or not. The first one, we need to see whether the power of any alphabet is in root or not. Or the second one, they should not be in denominator. Alphabet should not be in denominator, it should not be in the form of fraction, and there should not be any root. So these are the main conditions to make any equation not to be polynomial. So this was our first question. Even one more question is there. Question number 5. It's given x raised to 10, y raised to 3 and t raised to 50. Now this is also a polynomial. But in our question it was given whether the equations are polynomial in one variable or not. So we'll write yes, it is a polynomial, but not in single variable. Here total 3 variables are there, x, y and z. As it is a polynomial, but not in single variable. So this is our first question over. Now let's start out with the second question. So first question is quite easy, which they will ask in MCQs only. So here they will be giving an equation and they'll ask whether it is polynomial or not. To make any equation polynomial, we need to keep in mind, we need to make polynomial. To make any polynomial, we need to see whether the degree, whether the alphabets are in root or they are in denominator. If these two conditions are there, they are not the polynomial. Other than that, with any power, they can be polynomial. In your syllabus, you are having only linear, quadratic and cubic polynomial. So you need to concentrate only 3 powers. If power is 1, we call it as linear polynomial. Power 1 means when the degree of x is 1, we call it as linear polynomial. If the degree is 2, we call it as quadratic polynomial. If the degree is 3, we call it as cubic polynomial. So this is the first condition. Now let's start out with the second question. Okay, let's start with second question, where we need to write the coefficient of x square. So here our question number 2, it's given write coefficient of x square. So here the first question, what is coefficient? Coefficient means what is there before x square. So here equation is 2 plus x square. So here equation is 2 plus x square plus x. We need to write what is coefficient of x square. Here nothing is there before x square, which means 1 is there. If no number is representing before the term, we consider it to be 1. Therefore, coefficient of x square is 1. Therefore, coefficient of x square 1 for this first question. Now let's start with the second question. Second question is 2 minus x square plus x cube. Here again there is nothing before x square, so we consider it to be 1. So therefore again the coefficient of x square is minus 1. Now third question, it's pi by 2 x square plus x. We can see that pi upon 2 is there before x square. So therefore again the coefficient of x square here pi by 2. This kind of questions are very simple. Only we need to see that what is there before x square. Before the term x square there is pi by 2. So the coefficient is pi by 2. Now in fourth question, you can find that there is no x square term. Here we are having the term with x and only number is there. This variable value is there. There is no x square. So therefore coefficient of x square is 0. I am not writing this complete sentence. By giving the answer, you need to write this whole sentence, coefficient of x square. So I gave only one example. Rest of the examples, everyone can follow out in the same way. So whenever we are writing any coefficient, we need to put what is the value there before the x square term. Here before x square minus 1 is there. So coefficient is minus 1. Nothing means I made it 1. Here before x square pi by 2 is there. Now in the fourth question, x square term is not there at all. So we considered coefficient as 0. If term is not there, we cannot write 1. If term is there but no value is there before it, then it is 1. Now the second question is over. Now the third question, we need to give one example for each of binomial with degree 35 and monomial with degree 100. So what we call third question, we need to give example of binomial and monomial. So what is binomial and monomial? Binomial is a polynomial where there are two terms. Bi means two terms, mono means one term. When there is one term, we call it as monomial. When there are two terms in any polynomial, we call it as binomial. We need to write example of both. So let's start out with the binomial example. As it is binomial, we can write any two different alphabets over here to make it binomial. Now, if suppose it is monomial, only one term to be there. So as it is binomial, I have taken two terms, and then the degree of this binomial must be 35. You can put 35 on any variable. Now, it's not that we should not take the letters with the power. Here we can, here we can write x square, y raised to 35. We can write x12, x22, x32. The condition is that the highest number must be 35. Whenever we are making binomial, the two different alphabets should be there and highest degree must be 35, as they have given the binomial to be with 35. Now second question, we need to write monomial. So here monomial of the question, like we need to write any monomial. So I'm using the letter x over here. Degree is given 100. So write down 100 for that. So this is how we are going to make the solution. Now this third question is over. In question number 4, we need to write degree of each of the following polynomial. So already I taught how to write degree. Okay, we need to write degree for fourth question. Now here, question number 1, 5x cube plus 4x square plus 7x. So whenever we find degree, now we can find out this is a trinomial. 1, 2, 3. 3 terms are there. Depending on the terms, we consider whether it is binomial, monomial or trinomial. If 3 terms are there, trinomial. If 4 terms are there, quadrinomial. If many terms are there, polynomial. If only 2 terms are there, binomial. Only 1 term is there, monomial. And the degree of the polynomial or degree of any polynomial is the highest power. So for this case, the highest power is 3. Thus the degree is 3. Now second question, 4 minus y square. Here 2 terms are there. So it is binomial and degree, that is highest power, is 2. So degree is 2. Third question, 5t minus root 7. Here number is having root. There is no root on alphabet. So it's a polynomial. And degree is highest power. If no value is there, means it is 1. Thus it is having the degree 1. It's a binomial, 2 terms are there and nothing, no power is there on alphabet. So degree is 1. Fourth question, here only value is there, only number is there, no alphabets are there. First of all, we should not consider it to be polynomial. Here only 3 is there, only will be representing degree. Whenever any number is there, we call the degree to be 0. So most probably everyone are understanding. Here no alphabets are there, only degree they asked. So degree is 0, but it's not considered as a polynomial. Next question number 4. This also, while having the introduction, we discussed whether the equation is linear or it is quadratic or cubic. Depending on the power, we classify them. So here, first question, x cube plus x is there. It's x square plus x. As the degree is 2, we call it as quadratic. When the degree is 2, we call quadratic. If the degree is 1, linear. If degree is 3, we call it as cubic. So here degree 2 is there. So it's a quadratic polynomial. Second question, it's given x minus x cube. Here degree is 3. Thus it is cubic polynomial. Now third question, it's given y plus y square plus 4. Again the highest degree is 2. So it is quadratic polynomial. Fourth question, 1 plus x. No power, so degree is 1. When degree is 1, we call it as linear polynomial. Now next, in fifth question, it's given 3t. Again there is degree 1. It's a monomial as only single term is there, and degree with 1, so it's a linear polynomial. Question number 6, r square is there. It's again monomial as single term is there, and degree is 2. When degree is 2, we call it as quadratic polynomial. So this is how we completed our first 2.1, that is first exercise of 2. Very easy sums are there, simply everyone can get. Only the basic concepts you need to understand, what is degree, and then how we classify a polynomial, whether it is linear, quadratic or cubic, and how to represent monomial, binomials. So this first exercise is purely based on MCQs. You are going to get only MCQs out of that. The second exercise is little tricky. This whole chapter is very interesting. What you did in your 8th standard, this is the continuation of that. So let's start out with the second exercise now. Now let's start with 2.2. So here we need to find the value of the polynomial. So here we need to find value. They'll be giving certain value for x. We need to calculate what the complete polynomial will be. So here it is given 5x minus 4x square plus 3. We need to find it at x0 when x is 1 or when x is 2. We need to find its value at different 3 stages. So I'll start out with, so first I'm using x as 0. So when we replace x with 0, the whole term will become 0. When we multiply any term with 0, so whole term will be 0. So this first 2 terms became 0. So the value is 3. Now the net value of the polynomial is 3. So this is our first question. Now the second one, where we need to replace x with 1. Minus 1. If we are replacing x with minus 1, what will be the value of polynomial? So that we need to find out. So plus minus minus, thus it is minus 5. If we make the square of minus 1, this will be plus 1. 1 multiplied by minus 4 plus 3. Now it is minus 9 plus 3. Minus 9 plus 3 is minus 6. So the value of polynomial is minus 6. Now the third question, again the same equation or the same polynomial, we are replacing x with 2. We replace x with 2. So it is 10, 2 to the 4, 4 4 is 16 plus 3. Now 10 minus 16, it's minus 6 plus 3. Minus 6 plus 3 is minus 3. So these are the values of the polynomial which we are getting if we use the different values of x. Now the next question. Now question number 2. Question number 2, it is given, find p of 0, p at 1 and p at 2. So here the values of x is given. So we are finding the polynomial value where x is 0 or x is 1 or x is 2. So the different conditions are there where we need to find the value of polynomial. This is also same as we did for question number 1. So out of here, the first question is p of y, where the polynomial is y square minus y plus 1. So always consider, as I told, like polynomial, we should not make it equal to 0. If the same equation we write by making it equal to 0, it is called quadratic equation, which we have again the chapter in 10th standard. So here we are having only polynomials, so never put the 0 here. We need to put 0 for y. So a single question to be done by using 3 different values. So if we put 0 in place of y, again y 0 square is 0, so we'll be having only the value 1. Now second question, where we need to repeat the same question only, we are repeating it 3 times. This is the main question 1. So we are repeating it 3 times with the 3 different values. Now replace y with 1. 1 square is 1. Now plus 1 minus 1 plus 1. So value is 1. Now replace the equation. We need to replace y now with 2 as the 3 different values 0, 1 and 2 is given. So let's replace y with 2 now. 2 square minus 2 plus 1. 2 square is 4. Minus 2 plus 1. 2 minus 2. 4 minus 2 is 2. 2 plus 1. 3. Thus the final answer is 3. So this is how you need to represent. Whenever you are solving, so represent all the methods properly and final answer to be highlighted. Here we got y as 1 for the first question. Second question also 1. And third question we are getting it to be 3. Now let's start with the second question. Second question is given P of P is 2 plus T plus 2T square minus T cube. Now replace T with again as the value was given 0, 1 and 2. So replacing it with once with 0, then with 1 and then with 2. So if we put 0 in place of T, sums are quite easily everyone can solve. So thus here 0 is having no values, so all the terms will become 0. Thus the value of the polynomial is 2. This first question. And the second sub question, where we need to replace the equation with 1. So replacing T with 1. 1 square is 1. 1 2s are 2. 1 cube is 1. Now plus 1 and minus 1 will get cancelled. 2 plus 2 is 4. Thus the value of the polynomial is 4. Now the third question, where we are replacing T with 2. So here 2 square and 2 cube. 2 square is 4, 4 2s are 8 and 2 cube is also 8. So both will get cancelled. The answer is 2 plus 2, 4. Now third question, it's given P of x as x cube. Again we need to replace it with 0, 1 and 2. So the first case we are replacing the equation with 0. 0 cube is 0 only. So answer is 0. For the second case we need to replace x with 1. 1 cube is 1. Thus the answer is 1. And for the third case we need to replace x with 2. We need to replace x by 2. Thus it is 2 cube. 2 cube is 8. So when we considered x as 0, we got the value as 0. If x is 1, we got the answer as 1. And when x is 2, polynomial's value is 8. Now let's start with fourth question, where P of x is given x minus 1 multiplied by x plus 1. So here directly we can apply identities. So many students put over values here. They replace x with their given values. We should not do in that way. Always first solve the polynomial. First you get it the complete solved way, then replace the value of x. So when it is x minus 1, x plus 1, already in last standard. So in the previous class you learned this identity. So it's x square minus 1. Now replace x with 0. So as the first value is 0, 0 square minus 1. So answer is minus 1. We can start out from this equation as we got the final equation. For the second case, we need to replace it with 1. So I'm replacing x with 1. 1 square is 1. 1 minus 1. So answer is 0. when we were having x as 0, so it was minus 1. If x is 1, it's 0. Now again we need to replace x with 2. So replacing x with 2, 2 square minus 1, 2 square is 4, 4 minus 1 is 3. So we got the three values of the polynomial by using the different values 0, 1 and 2. Now let's start with third question. In question number 3 it is given, verify whether the following are zeros of the polynomial. So here you are getting the new word zeros. So zeros means whether the equation when we solve, like in your 8th standard you are having linear equation in one variable. So there you are solving equation x and you are getting the value. So when we solve, so what the value we are getting, whether it is the answer of that equation or not. So if it is the answer, we call it as 0 of the polynomial. So as degree is there, degree is different and 0 is different. 0 is the final solution for the x, or we can say value of the x. Okay, whether they are zeros of the polynomial or not, we need to verify. Here the question is given p of x, it's 3x plus 1 and x is given minus 1 upon 3. So when we solve this equation, we need to see whether we are getting x as minus 1 by 3 or not. If you are getting x as minus 1 by 3, then it is 0 of the polynomial. If the value is not matching, we say it is not the 0 of the polynomial. So we can solve this equation in two different ways. The first one, either we can replace x with minus 1 by 3 or we can compare the equation with 0. As it is given, it's a 0 of the polynomial. So equation will match out with 0. If we are getting the same answer for x, we consider it to be the 0 of the polynomial. 3x, as in the 8th standard you are solving for x, the same method you need to follow out. Shift 1 towards left. So it's minus 1. Now x is minus 1 upon 3. We got the same answer which was given in the question. So we'll say S, it is the 0 of the polynomial. S given value is 0 of polynomial. Now the second question, it's given p of x 5x minus pi and x is given as 4 upon 5. Again we compare the equation with 0. So once I explained you by comparing, now I'll replace the value with 4 upon 5. Now I'll replace x with 4 by 5. So x replacing 4 by 5. So it's 5 getting cancelled. 4 minus pi. We are not getting answer as 0. So these are the two methods how we can consider whether the given value is the 0 of the polynomial or not. So now if we get 0 over here, so it's a 0 of the polynomial. As we are not getting 0, so it's not the 0 of the polynomial. If same question I'll do by comparing. If I'll compare it with 0, 5x is equal to pi. So x is pi upon 5. X, if it is pi upon 5, then we could have got the value as 0. So this is the 0 of the polynomial. 4 upon 5 is not the 0 of the polynomial. So answer is no, given value is not the 0 of polynomial. Now third question. Where p of x is given x square minus 1, x is 1 and minus 1. We need to replace x with two values. It can be either plus 1 or minus 1. Now if x is plus 1, how we will get the value whether x 0 of the polynomial is plus 1 or minus 1. So we'll be verifying by putting the different values 1 and again with minus 1. Now the first case, if I replace x with plus 1, or as we were solving for the first, like previous case as I explained, we'll compare it with 0. So this is more convenient method to get the answer directly instead of replacing the value. So I consider this equation as 0. So x square is 1, x is root over 1. Whenever we find square root of any number, now onwards 9th and 10th standard, we need to write the answer with positive and negative value. So here, if we get the root of 1, square root of 1 is 1 only. It can be either plus 1 or minus 1. How we got plus 1? When we multiply plus 1 with plus 1, answer is 1. If you multiply minus 1 with minus 1, then also answer is 1. So whenever square root of any value is taken, we need to represent it in positive and negative. We need to represent it with both the signs. Keep in mind, for 9th and 10th standard, now onwards we are representing any root values with both the signs. So as we got both plus and minus, so answer is S, given value is 0 of polynomial. Now next question, fourth one, it's given x plus 1 and x minus 2. P of x is x plus 1 and x minus 2. So as I told earlier, first we need to solve the equation. Don't put out the values directly. And the values of x are given minus 1 and 2. So this question we need to solve twice to verify whether these are the zeros of polynomial or not. So we are multiplying it. In next exercise 2.4, you are going to get a direct formula where you can multiply the term directly. So here, as that exercise is not yet explained, so I am starting with the expanded multiplication. First take this x and this whole bracket to be taken. Now the second term and again whole bracket. Multiply it. X square minus 2x plus x minus 2. X square 2 plus minus 2 plus x is minus x minus 2. Now we got the equation. We need to replace this equation once with 1. So I am replacing x with 1. So it's given minus 1. Minus 1 square is 1. Minus minus plus minus 2. Plus 2 minus 2. They get cancelled. Answer is 0. So S, it is the 0 of the polynomial. Now the second term, we need to replace it with 2. So I am replacing the equation with 2. 2 square minus 2 minus 2. 2 square is 4 minus 2 minus 2. Again 4 minus 2 is minus 4. For both the cases, we got the answer as 0. So our final conclusion is S, the given value is 0 of the polynomial. So most probably everyone are getting. So let's move with the next question. Now let's start with question number 5. So fifth question, it's given P of x is x square where x is 0. We need to replace x with 0, so it's quite easy solution. If we replace x with 0, answer is 0. So as it was given, 0 is the solution, and after solving we are getting 0 only. So as the given value is 0 of polynomial. Now for sixth question, as in your exam you will be getting this mostly in MCQs, or if they will ask for like unit test, they can ask this to solve. You will be getting 2 or 3, maximum 1 or 2 questions. Don't simply write S like me. So you need to write complete statements. As the given value is the 0 of the polynomial, you need to represent the full sentence. Whatever given in the question, you need to represent answer in the same way. Question number 6 is given Lx plus m, where x is minus m upon L. Now here I am replacing x with minus m upon L. So I am solving the equation with both the methods. Either we can replace this value or we can consider it to be 0 and find out the value of x. L is getting cancelled, minus m plus m. So both again got cancelled. Answer is 0. As we are getting answer as 0, so therefore as the given value of x is the 0 of the polynomial. Now seventh question, it's given 3x square minus 1, where x is minus 1 upon root 3. Now replace x with minus 1 upon root 3. Here x square is there. Whenever we make square of any root number, so square will get removed. Thus answer is 3 multiplied by 1 by 3. We are making square of minus 1 by root 3. So minus 1 by root 3 square will be 1 by 3. 3 is getting cancelled. 1 minus 1, 0. Again, as the given value is 0 of the polynomial. Now last question of this question number 3. So last 8th question is given. P of x is 2x plus 1, where x is given 1 upon 2. So let's start with the previous method where we were comparing it with 0. Both the methods are there. Whatever you feel easy or convenient, follow that one. So shifting 1 that side, so it's minus 1. X is minus 1 upon 2. Whereas the given value was plus 1 by 2. They are not matching. So as we got mismatched value, so the statement is no, the given 0 is not the given value is not the 0 of the polynomial. For all the answers you need to write the statement, given value is not the 0 of polynomial. So this is how we solve this exercise. Now one more question is there in this exercise, question number 4. With that, this 2.2 exercise will get completed. So let's start out with question number 4. Now question number 4, we need to find 0 of polynomial. Here P of x is given x plus 5. So as I told, we need to compare this with 0. So x plus 5 is 0, thus x is minus 5. Therefore 0 of polynomial is minus 5. So this was the first question. Now second question is x minus 5. So again I'll compare it with 0. So x is 5. Therefore 5 is 0 of the polynomial. You need to write the statement for every answer. So I'm not repeating it again and again. So everyone can repeat that answer in detailed form. Now the next question, third one, is 2x plus 5. Again we will consider it to be 0. So 2x is minus 5 and x is minus 5 upon 2. Therefore minus 5 upon 2 is 0 of the polynomial. Now question number 4. Here it is given 3x minus 2 P of x. So we'll compare it with 0. 3x is shifting to that side, so it will be plus 2. So finally x is 2 upon 3. Therefore 2 upon 3 is 0 of polynomial. Now fifth question, it's given P of x 3x. So again we'll compare it with 0. So x is 0 upon 3, which is 0. Therefore 0 of the polynomial is 0. Now sixth question, it's given P of x is ax. So directly we are going to compare ax with 0. Thus x is 0 upon a. Any number divided by, if we are dividing 0 with any number, so answer will be 0 only. Therefore x is 0. 0 is 0 of polynomial. Now the seventh question and last question of this exercise, where it is given P of x is cx plus d. So compare the cx plus d with 0. Cx is minus d, x is minus d upon c. So minus d upon c is 0 of polynomial. So most probably everyone understood this. So this is the video of our two exercises, 2.1 and 2.2. In the next video, I'm going to upload 2.3 and 4. So for continuation, all of you watch the next video also. Thank you for seeing.